95%. That sounds excellent. If someone told you a tool got the right answer 95 times out of 100, you would probably trust it. Maybe not blindly, but enough to use it. Enough to feel reasonably comfortable putting your name on the result. Now, what happens when the work has more than one step? Two steps, each 95% reliable, gives you about 90% for the whole chain. Five steps, about 77. 10 steps, roughly 60. And 10 steps is not some absurdly complicated workflow. Pull the data, clean it, check it, summarize it, draft the answer, format it, compare it with the original, fix the references, send it on. That's just a normal Tuesday morning. Now, before someone pauses the video with an angry comment, this is a simplified example. Real errors are not always independent. Some steps catch mistakes from earlier steps, some do not. The point is not that every tool with 95% accuracy will fail 40% of your workflows. The point is that accuracy on one isolated task is not the same thing as reliability across a job. You'll almost never see that distinction in a launch announcement. So this video is a toolkit. 5 questions you can ask whenever somebody says a piece of AI can now do something extraordinary. They work whether the claim comes from a giant technology company, a consultant, your boss, a bloke on LinkedIn, or me. Quick disclosure, I use these tools every day. I'm not here to tell you that they do not work. I'm here to help you work out when they work well enough for the thing that you actually need done. There are 2 different claims that get made using almost identical language. Separating them is most of the battle. The first is the capability claim. Can this thing, under some conditions, produce the right output? The second is a reliability claim. Will it produce the right output on my material in my workflow often enough that I can depend on it? A lot of public discussion starts with a capability result and quietly turns into a reliability promise. The model did it once, therefore the model can do it. The model can do it, therefore it can do my job. Those are 2 different statements. They just tend to arrive wearing the same coat. I'll give you my version. In my day job, I produce geological work that other people rely on. Plans, interpretations, sections, reports. When that work is reviewed and signed off, it carries professional weight. Somebody may make a planning, operational, or investment decision based on it. An AI tool that gets 95% of a task right could genuinely be useful for me. It can save hours. It already has. It is still not something I can put my name behind without checking. Those 2 things are not contradictory. In fact, that gap, useful but not independently reliable, is where most of the value currently lives. You'll have your own version. If you're a nurse, an accountant, a teacher, an engineer, a conveyancer, a project manager, anyone whose output gets relied on by somebody else, you already understand this. You would not accept usually right without asking what happens when it is wrong. AI should not get a special exemption because the answer arrives quickly and uses nice punctuation. So, 5 questions. Most impressive AI claims begin in one of 2 places: a benchmark or a demo. Both can be useful. Neither automatically tells you what will happen in your job. A benchmark is a defined set of tasks with expected answers. A model gets a score, and the score tells you how it performed on that test under those conditions. That sounds obvious. It is also the part that gets lost. 3 problems come up again and again. 1, narrowness. A benchmark tests a particular thing using particular inputs with particular rules. Your work is almost certainly messier. The PDF is scanned sideways, the spreadsheet has 6 different names from the same column, the client changed their question halfway through the email and forgot to mention it. Benchmarks rarely contain Greg from accounts. 2, contamination. These systems are trained on enormous collections of material. Some benchmarks, or closely related examples, may appear in that material. When that happens, a score can partially reflect familiarity or memorization rather than general performance on a genuinely new problem. Researchers still argue about how to detect this properly. That is the point. It is a real evaluation problem, not a neat little footnote. 3, reporting. There is a large difference between it solved a task on the first attempt and it solved the task at least once after several attempts with carefully chosen instructions, and we are showing you that result. Both can demonstrate capability, only one tells you much about dependable everyday use. A demo has an even simpler limitation. Somebody chose it. They chose the task, the input, the prompt, the framing, and most importantly, the take you are watching. That is not automatically dishonest. Every product demonstration in history has shown the product working. It just means a demo is evidence that something is possible. It is not evidence that it is typical. So, question 1 is, who ran the test? under what conditions, and could I repeat it on my own material? If you cannot answer that, you still may have a true claim, but you have not yet got a result you can price a business decision around. You have got an advertisement. This catches an extraordinary number of bad claims, and it is almost embarrassingly simple. Whenever you see a claim about what AI achieved, ask out of how many? The system discovered a novel solution? Out of how many attempts? 1, 10, 400? Users reported major time savings? Which users? Everyone who received the survey? Or the people who replied? It passed the exam? Which version? Under what conditions? At what percentiles? How many attempts were allowed? The missing denominator has a funny habit of disappearing in only one direction. It rarely makes the claim look less impressive. There is a specific version of this in productivity studies. A study finds that people using an AI tool completed a task faster. Good, that matters. Then you look underneath it. Were the participants experienced at the task or beginners? Was the task representative of real work or something clean enough to finish inside a study session? Did anyone check whether the quality held up? Did the participants have unusually good support? And was the gain still there once the novelty wore off? None of those questions proves the study is wrong. Some studies are excellent. It means the conditions are part of the result. When somebody lifts one number out of a paper and puts it in 48-point font, the conditions are usually the first thing to go. Question 2. Out of how many and under what conditions? This is the one I would keep if I could only keep one. Accuracy is only half the picture. The other half is the cost of a mistake and whether you are likely to notice it. Think about 2 tasks. First pass email draft. If it is wrong, you notice immediately, change 2 lines and lose 15 seconds. Now imagine summarizing 40 pages of a contract. The summary looks excellent, clean, confident, completely plausible. It also quietly leaves out the clause that matters, and you may not discover it for months. Same tool, same nominal accuracy, completely different risk. That is what makes AI errors awkward. The wrong answer often arrives in exactly the same confident, fluent voice as the right one. There is no nervous pause, no "I might be wrong here," no visible sweat. A colleague who is unsure will often signal it. The machine probably won't. And asking it to provide a confidence score does not magically turn that score into a calibrated instrument. So the mistakes that hurt are not always the ridiculous ones. They are the plausible ones. The reference that looks real, the number that is the right shape but the wrong value, the summary that is accurate about everything it mentions and silent about the one thing you needed. Question 3. If this is wrong, will I find out, and what will it cost if I do not? When the answer is probably not, and quite a lot, a headline accuracy figure is not enough. This is no longer just a tool choice, it is a process design problem. Pilots are where software looks good. Rollouts are where software meets Darren's spreadsheet. A pilot usually has motivated people, selected data, clear goals, and somebody from the vendor sitting nearby to help. Then the tool rolls out across the organization. It meets real data, real deadlines, people who did not volunteer for it, a process that was already held together with email, habit, and one person who knows where the old template lives. That is when you learn whether it actually works. The successful pilot gets a case study. The quiet abandonment 6 months later usually does not. So, when you see a success story, do not only ask whether it worked at launch, ask what happened next. Is it still in use a year later? How many people are actually using it? What work has it genuinely replaced or improved? If nobody can tell you, you may be looking at a launch rather than a result. You can apply this inside your own organization without a research budget. Ask what happened to the last tool everyone was excited about. Ask how many licenses are active. Ask who still uses it when nobody is standing over them. That answer will tell you more about your organization's readiness than another slide about transformation. This question gets used badly, so let me be clear about what it is not. It is not everyone making an AI claim is lying. I do not believe that. It is also not a useful way to understand the world. The question is about incentives. When somebody strongly wants a claim to be true, financially, professionally, emotionally, that affects what they test, what they notice, and what they repeat. They may still be completely sincere. Sincerity does not remove the incentive. It just makes it harder to see. So work upstream. Who produced the result? What outcomes helped them? Who funded the work? And is there anyone with expertise to evaluate it who does not need the answer to be impressive? That group exists. Independent researchers, evaluators, practitioners writing honestly about failed deployments, people who tried the thing on ugly, real-world material and discovered where it broke. They are usually less exciting to read, but they are often where useful information is, and it's honestly what I hope this channel ends up being. Question 5. Who is upstream of this claim and what do they need to be true? Put the 5 questions together and the whole framework fits on one screen. 1. Who ran the test and could I repeat it on my own material? 2. Out of how many and under what conditions? 3. If it is wrong, will I notice and what will it cost? 4. Is anyone still using it a year later? 5. Who is upstream of the claim and what do they need to be true? And I would add one habit worth almost as much as the 5 questions combined. Test the tool on your worst realistic input, not the best one. Everyone wants to evaluate AI using something clean and interesting. Do the opposite. Give it the scanned document with a coffee stain. Give it the spreadsheet where half the dates are stored as text. Because that is the work. If the tool handles your ugly, ordinary material, you have learned something useful. If it handles the perfect example you designed to suit it, you have mainly learned that demos work. One last thing, because I don't want this framework to turn into automatic cynicism. Every one of these is a good faith question. You can ask all 5, get sensible answers, test the tool properly, and decide to adopt it. That happens all the time. The questions are not designed to protect you only from fraud. They protect you from something much more common. A true claim made honestly about a narrow result, which gets a little broader every time it is repeated. By the time it reaches you, nobody has technically lied. The claim has just grown legs and wandered away from the evidence. You are going to be asked to make a decision about these tools. At work, in a business, maybe about your own career. You will not have time to become an expert on every system that gets announced. You do not need to. You just need these 5 questions, one ugly test file, and the discipline to check before you believe the headline. That's it. Every source I used in this video is linked below, including anything I couldn't independently confirm. If you want more evidence-led AI stories with an Australian context, hit subscribe. There's a new video every Friday. No hype, no doom, just evidence. See you Friday, regulars.